What's the chapter 19? Lenses. 透鏡啊，中文叫做光學透鏡。So this one in this chapter is very important in examination. Maybe one long questions because you will draw the diagram, complete the diagram, and then find out something. Here we have 4 sessions, a very important one. Now let me to start the first one, 19.1. Here, basics of lenses. What is it? Actually, lenses, most of you have carried it because you have short-sighted or long-sighted. Here, the common lens, what is it? Actually, it will be a glass in different curvature, 唔同嘅弧度. And then this one, we can make it different lenses. So here, in our, okay, this one is the spelling mistake. In our daily life, lenses actually is a combination of lens. But what's the main purpose of it is to reflect light, 令到啲光行歪咗。行歪咗，點行歪啊？會解釋，等一等。The most common example for you will be camera lens inside this camera. Or you may use contact lens. This one is also a lens. Sometimes when you want to magnify something, you will use the magnifier. Magnifier is also a lens. Now, this one is the principle of the structure of a lens. Lens is constructed by transparent material. Usually it will be glass. But nowadays, we will use the other, for example, the plastic. Okay, purpose to do it. Now here, we should determine the type of the lens. We will have 2 types. The first type we will say that convex. The other one is concave. Convex in Chinese, 凸鏡、凸透鏡. Concave, 凹鏡、凹透鏡. But how to determine it? You should determine it by the thickness. For the center one is thicker one, then we will say that convex. For the thinner one, we will say that concave. So when you have, if you wear glasses, and also if you have short-sighted, you can touch your lens. You will feel that the center one thinner. Okay, the center one will be thinner. The outer one should be thicker because you are short-sighted. For the short-sighted person, you should wear concave lens. But why? I will tell you later. Next one, for convex lens, if you have long-sighted, try to fill in it. The center one will be thicker one. Outer one should be thinner one. But most of you, if you wear glasses, you will feel that all of them, the shape of your lens will be this one and this one. You will feel that the outer part should be like that, the curvature. Similar to a convex lens, 凸咗出嚟嘅，凸咗出嚟嘅。點解呢？ Reduce air resistance when you're walking. Okay, so usually we will don't use this one and this one. We will make the shape like this. But how to make it? Let me to draw the diagram. Originally, for the concave lens, should be like this. Center one should be thinner one. Now we can modify it to make this curvature straight and make this curvature more curved. Then what will happen? Like that. Make it straight and more curved. But this part is also have a great air resistance. So we will try to make this straight part more curved in the other way around, like that. Then how about this part? Okay, should make it more curved, like that. Then this one will be your practical concave lens for you to wear. Okay? That's all. But of course, up to now, you should know that these 2 terms, convex and concave. But what are the differences between them? I will mention it later. here. This one will be the physical shape of the concave and convex. Unfortunately, we haven't any face-to-face lesson. I can't show you this. Okay. Now look at this. How to determine that this one is a concave or convex? Exactly the same. Center one thicker, concave. Center one thinner, concave. No. My spelling. This one. For convex one, center one thicker. For concave one, center one thinner. This one also. You can see that this part should be thinner. This part should be thinner. And also, for the length, we have two types. Cylindrical. Cylindrical means that coming from a cylinder, glass cylinder. I cut this part out, will be this. Okay? How about this? For this, how to do it? We will have this one, and then put a cylinder here. This part will be a concave lens. Can you see it? Okay. Now, next one. Spherical, how to come out? We will have a sphere, and then cut this part out. Will be this convex lens. Similarly, if this one is a mold, outside it we have the glass, like that. Then this part will be concave lens. They are different. The result of for the image, I will mention it later. Now this one. How a parallel light bend when they pass through a lens? This one, convex and concave. Here we have experiment. This one. This one, convex and concave. Ask you how to do it. And then, how do the path of the light change after passing through a convex and concave lens? Here. This one is the discussion part. Show it on your textbook already. Actually, we haven't this experiment. Very difficult to see it. We want to see the result first. Okay, look at this. This one is the preparation. We have the power supply. We have the light box. And before it, we have two different lens. Usually, we will put it on a sheet of paper to let us to see it more easily. Connected to the power supply. Here, what you do? Actually, you should mark the position of the light using 2 points. Can you see it? You can put the lens into it. Initially, you can see that the light will change direction. But up to this position, you can see that no change in direction. This one should be a straight line. What is it? Normal instance. This one is 90 degrees, and this one is also 90 degrees. Remove the lens and then mark the center of it. This one, we call it center. You can use the ruler to draw a straight line. This straight line means that pass through the center. And this line, we will have a special name. Okay, this special name is principal axis. Now put it back, put the lens back to the position. Also a straight line, no problem, because this one is the normal instance. Now remove the slit, let all the light coming from it, and change the slit from 1 slit to 3 slits, and then mark the position of the light ray. You can see that these 3 light rays should be parallel to each other. The center one should go to the center and then come out straightly. But the other two, top and bottom, what will happen? You can see that they will change the direction. Finally, this free light wave will come to the same point, this point. In later part, we will call this point focus, 焦點. Now in this experiment, draw all the light wave using the marker. We mark it already, and remember that to add arrows to show that the direction of the light. Okay, draw the arrow. And then how about this one? This one, we will say that reflected, 折射嘅光線. This one will pass through the intersection point here. This intersection point, we will call it focus. Once again, you should draw arrows to show that the direction of the light. This one is a practical skill using the light box to help you to draw the light wave. And usually for this focus, principal focus, we will use capital letter F to stand for it. C stands for center. The center line, say that's principal axis. This one is for convex lens. And here, draw a straight line to pass through the principal focus. This line, what will we call? Focal plane. What is the definition of focal plane? Means that this very special one. Originally, we have three parallel lines. But now, we also have three parallel lines, but not parallel to the principal axis. Then what will happen? These three parallel lines also have the intersection point, but not on the principal focus. At the intersection point will be located at the focal plane. This one is the characteristics. Of course, I will explain it. But this one just only an experiment to show you the final results. The explanation, I will explain it later. Once again, this plane call it principal axis and also the focal plane. Now, for next one, concave lens. What should do? Exactly the same. Draw the principal axis first and locate the center here of the concave lens. Okay, draw the principal axis, put it back. Now, if we have three light waves parallel to each other and then emerge into the concave lens, what will happen? You can see that these three light waves will spread like that. They will not come together to have intersection point. They will spread. But when you when you mark the marker and then remove the lens, and then you can draw the light wave. I speed up it. You can see that these two points, okay, can link up to here, spreading. The upper one, only the center one is into a straight line. Now, what is it? We can try to extend this light wave using the dashed line. Dashed line means that not the real one. But you may ask that why we need to extend it. Because your mind has problem. You will think that the light is a straight line coming from a certain light source. So this dashed line means that a construction line to help you to locate the light source. But this light source is not actual one. In your mind, you think that all the light should be coming from this. Then this one, we also call it focus. We will think that from this focus form, all the light should be coming from it and then into your eye. Because this one is the light source, all the light should be come out in all directions. So spreading is okay. The same, we can draw the focal plane. And we can put the parallel line in contact, not parallel to it. Then what will happen? You can see that this free light ray also spread out. Mark it. Okay. Finally, what will happen? Remove it. You have marked it. Draw the line. Finally, you can see that. Extend it. Finally, you can see that we have the intersection point here. We think that the light is coming from this source. This source should be on focal plane. Okay, that's all. This video is quite long, but tells you everything already. Here. Now look at this picture again. If you can see that three light rays come together, then this one we will say that converge, 聚焦. How about the other one? We will say that diverge, 散射，即散開啦嚇。聚焦係咪睇先中文叫集？先啦，記得咗個中文叫咩啦 ？diverge， 總之係散開咁嘅意思啦嚇。OK。This one is a simulation. Look at this. Okay. Exactly the same as the last one. Focal length is 5. What is the meaning of focal length? Focal length means that the separation between the lens and the focus. It means that this distance, we will call it focal length, 5 cm. If this one is 50 cm, it will be further away. Okay. And this dashed line is the focal plane. Now, what will happen? Here, you can rotate. Can you see it? When I move it up, all the light ray will pass through the focus because these three light rays is parallel to each other. But now, if I turn it, can you see it? You can see that all the light will have an intersection point, but not on the principal focus. Will be on the focal plane. But where's the focal plane? Actually, focal plane must pass through the principal focus. Okay. Now, how about 15 cm focal length? Here. Can you see it? Exactly. And then turn it back. Okay. That's all. This one is the convex lens. How about the concave lens? Similarly, but remember that all the light rays should be diverged. They will not have the intersection point, except we extend it. So that's the dashed line will be the extension. Here, this one, we will say that principal focus, and the dashed line, focal plane. Now, change it. 15. This one is 5, 15. Okay, now move it. Can you see it? If, once again, if this three light rays parallel to the principal axis, all the light rays should be coming from the focus using the extension line. Okay, your mind will think that all the light rays should come from here. But if this three light ray is not parallel to the principal axis, will be like that. This three light wave will be diverged, come out, and you will think that they will coming from this light source. But this light source, the position of it is not principal focus. So be on the focal plane. Okay, remember it. Now, this one will be the principle for the lens to have diverge or converge. How to understand it? Very easy. Here, you can divide this lens into many parts. The first part, prism. This part, also the other prism. Because this one is a glass, we will have refractive index. It means that the light wave come to here will have the change in direction due to the refractive index. Now what happened? Focus on it. Focus on the first part here. You can see that from air to gas, bend towards the normal, like that. And then from gas to air, bend away from the normal, like this. Then what can you see? You can see that original direction should be this. Now the light wave bends to the other position, the other direction. So you can see that this parallel line will bend downward. For this one, because the prism is upside down, then the light wave will bend upward. Finally, downward, upward, they will converge to a certain point. Other than the top and bottom, in the middle one, this one, normal instance come out. So this one must be a straight line. This position, we will call it center. How about the other part for this? For this, bend towards normal, bend away from the normal, the same. This one is the derivation angle. Okay, finally, all of the light wave will join here, intersect here. This position, we will call it focus. How about the concave lens? Exactly the same, but change the position of them. Once again, what is the convex lens? To converge the light wave, the shape of the convex lens is center, thicker, outer, thinner. Concave lens, center, thinner, outer, thicker. Just only change of that. Now, this one will be the final output. The middle one, normal instance, straight line. How about this part? Look at this. Less dense medium, denser medium, bend towards normal. And then come out, bend away from the normal. You can see that the change in the direction. This one is the derivation angle. So you can see that this light wave bend upward, this light wave bend downward. So it means that these two light waves cannot join together. Okay, but if extend it, they will join together. So this point, we will call it focus. Now terms for your lens on your page 240. Actually, all the terms I have mentioned it already during the last movie, the movie clip, the video clip. Now this one is revision again. For the center of the lens, we will call it optical center or center, never mind. F, we will call it principal focus or focus, no problem. And also, the center line, this line, we will call it principal axis. The green one, principal focus. For the plane, to pass through the principal focus, this one will call it focal plane. For concave lens, the same. Actually, for the focus, we have two. One is on the right-hand side, one is on the left-hand side. Both of them will have the same distance from the optical center. One of it we will call it F, the other one is F dash. We also have two different focal plane. And the separation between the principal focus and the optical center, we will call it F, focal length. Once again, this one is wave, but in this topic, optics, F is focal length instead of frequency. Don't mix them up. Now, next one, for the concave lens, the same. We have the center, optical center, the axis, horizontal line, principal axis. And also we have F and F dash, principal focus. The separation between the lens and the principal focus, we will call it focal length F. We have two focal plane. All the light rays should be diverged. But when we extend the line, we will have the principal focus. Optical center actually should be like this. We have the lateral displacement, 平移. It means that this one should not be a straight line. We will have a display laterally, no change in direction. But in our example, in our daily life, usually we will think that this lens is not too thick, then the lateral displacement is not large. In our examination, we can think that this one is a straight line. Okay, although you should know that if this one is too thick, this one should not be a straight line. We will have a lateral displacement. Okay, this one, the thickness is not too thick, then this one should be small lateral displacement. This one explains that in examination, usually we will call it thin lens, okay, what? Thick lens. Okay, usually we will use thin lens to make it lateral displacement as small as possible. Now, next one, focal length. We want to try to find out the relationship between curvature, material, and focal length. We want to find out the relationship. Look at this. If the lens more curve, it means that the derivation angle will be greater. Originally, it should be this direction. Now, change it in this direction. If like that, what will happen? More curved, then what will happen? You can see that the focus plane will be near to the lens. F should be smaller. How about this? Less curved. Then it means that the derivation angle, 偏差角度, should be smaller. Then F should be greater. How about this? If higher N, higher refraction index, greater effects, then what will happen? Should be this. Greater N, greater diffraction. So the intersection point will be located near to the lens. Okay, now final conclusion. This, the shorter the focal length, more light are bent. You can apply it both on concave and convex lenses. And also go back to here. What is the final result? Greater curvature. It means that this one, shorter F. Higher N, shorter F. Remember it. Okay? But of course, all of them should be coming from basic principle. Now, part C, wave diagram. This one is the main focus point in this chapter. You should draw the diagram. What should you do? The first thing is symbol. To make the wave diagram standard, so you should use the symbol to represent the standard lens. For concave lens, for convex lens, the shape of it should be like this. But in wave diagram, simplify it as a symbol like this. But how to do it? Very easy. Because this part, the upper part and lower part, exactly is a triangle. We will think that this one is the tip of the arrow. tip of the arrow. So like that. Or you can draw a dashed line to reveal the shape. But when you draw the diagram to simplify it, we will draw a double arrows like that. But how about the concave lens? Exactly the same. Outer one thicker, center one thinner. So you will think that like this. Okay? Up to now, you should know that how to draw the symbol of convex lens and concave lens. Next, very important. On your page 243, remember it. 但記住 remember 幾時 remember 咧？呢幾堂啦，記熟佢，記，之後你唔使記，因為你唔知點解要記得啦。Okay? Three different rules. The first rule, a thin line pass through the optical center will be a straight line. Okay? Although you know that we will have lateral displacement, because in examination we will think that this one is a thin lens. The lateral displacement is very small, so you can think that this one is a straight line. How about this? Normal instance, also a straight line. First rule, all the light ray pass through the optical center will be a straight line. Second rule, as showed you already in the video clip, if we have the parallel light ray, what will happen? It will bend, okay, towards, not normal, bend towards the principal axis. 嗱，最容易記嘅咩叫做 converge 啊？佢會更加接近 principal axis。當佢死嘅直行直角，而家你要 converge 咁點啊？就會接近個 principal axis。聽我講啦嚇，嚟緊好正嘅呢個。Converge means that the light ray will come near to the axis, okay, the principal axis. And then come to the principal axis and then cut the principal axis. This one, we will call it principal focus. Parallel, pass-through focus. Okay, and also in the last chapter, we know that the light ray can go back. It means that you can change the direction of the arrow like that. No problem at all. Okay, because they can pass through the same path. Then what will happen? We will have the third rule. This one. Reverse the direction. This one, parallel, pass through focus. If I pass through focus, then what will happen? Parallel out. This one. Pass through focus, parallel out. Is it converge? Again, you can see that negate it should be the dashed line. Now, you can see that this light ray will come near to the principal axis, converge. 好，中文講一次太重要啦。呢度有3個 rule for convex lens， 記住我哋呢3個 rule 要用嚟我哋畫嚟緊嘅圖。嗰3個 rule 係咩？第一，穿絲穿中間一定直線，你咩方向？第二個 rule 平入穿 focus 出，得唔得？要點嚟㗎？平入咩叫平入啊 ？Parallel to principal axis 就會穿 focus 而出。第3個 rule 係調翻轉嘅，穿咗 focus 就會平出。記住 ，OK？How about the concave lens? Exactly the same. Pass through the optical center will be a straight line. How about this? Parallel, but remember that this one is a concave lens. Okay, the characteristics of this lens is diverge. Okay, diverging the light ray. Then what will happen? It means that the light ray should not come near to the principal axis, will be away from the principal axis. You get it? So with this one, now away it means that in this direction. But of course, this light ray will have many directions to come out, but this direction should be extended to principal axis. 所以中文講一次， 平日點啊？散開，不過點散啊？對住個 principal axis 散開，你需要畫條輔助線，咁你就喺度再揾間尺一重，咁就畫到散開。Similarly 調翻轉，我將啲光調翻轉，即係話咩啊？我向住個 focus 開，佢就會平出。第三個 rule，我向住對面嘅 focus，咁點啊？當佢死嘅就直開，咁但係記住 diverge 會點啊？會離開個 principal axis，咁咪彈開咯。而特別嘅地方係彈開嘅時候就會平出啦，平衡出啦，得唔得？嗱，難記少少㗎，係要記，因為記得多咧就完㗎啦。好，我哋仲有5分鐘 ，check point one，咁就講完。OK，嚟咯噃。Here are the reflected light ray convergent, parallel or divergent。用翻我教你嗰啲嘢啦，咁啊萬事萬靈㗎啦。而家問你 to the left，OK，咁你就要做咩啊？你要決定翻咧啲光線係 converge 啊、diverge 啊定係 parallel。OK，light source 就有3條，咁最後尾佢停去㗎噃。OK，呢個叫做 converge，得唔得？嗱，咩意思啊？睇住咯喎，佢而家話俾你聽，如果將個 light source 褪後少少，去邊度啊 ？To the left，即係褪後少少啦，你會變咗咁樣。嗱，以下動作咧幾難做嘅，喺實際堂上咧就會易做啲。我嘗試下畫佢出嚟咯喎嚇。原先你會發覺由個 light source 出嚟就平出嘅，咁其實已經暗示咗俾你聽咧，其實 light source 個 location 咧其實 focus 嚟嘅，不過唔重要。最重要係咩嘅咧？如果將呢個 light source 褪後，咁我又去翻啲點喎，咁即係話我要畫條藍色線啦，咁樣去。咁跟住點啊？唔識畫喎，好睇住。而家咧，我哋頭先已經知咧，就呢條光線直開，原來佢 bend towards 個 principal axis 嘅，咁即係話呢個做緊 convergent 啦。既然係做 convergent 嘅話，會點咧？你就幻想將呢個紅色 rotate 少少。點樣 rotate 少少啊？好似將呢條線咧就 rotate 到呢條線嘅方向，咁啊睇住咯喎。嗱，藍滑啲啊，咁樣原先咁樣嘅，而家我將呢個 rotate 到變成咁樣，我又轉翻做紅色咯喎，變成咁樣。如果咁樣嘅話會點啊？咦，好似呢個嘢咧就轉咗去 clockwise direction。咁呢條線咪應該要轉 clockwise direction，即係轉下咯，變成咁啦，得唔得？嗱，記住似啫，唔係 exactly 㗎嚇。我好嚴重地話俾你聽，D 值原本嘅角不等於 D 值角，因為佢背後咧仲有啲比較複雜嘅計數嘅嚇，佢哋唔係一樣嘅。但係用呢個方法咧係接近做到類似嘅 prediction 嘅，所以你會見到實線就咁樣啦，好似將個實線嘅橙色實線咧，好似 rotate clockwise 嘅 direction 就變成虛線嗰啲線，得唔得？咁你就可以估到會係咩㗎啦。嗱，記住估嘢咧，用呢個方法估嗰啲嘢咧，通常係 level 4問題。嚟緊會講。好，先問下你啦，用翻我教你嘅方法，今次就係咩 ？Move slightly to the right hand side. It means that the source should be near to the lens. Then what will happen? It means that this 好似將呢條線咧褪去呢邊，咩方向啊 ？anti-clockwise。咁嘔出嚟嗰條線會點啊？都係轉 anti-clockwise，咁就唔使諗啦，變成咁啦，係咪好易咧？跟住，喂，咁你見到呢條線飛走，呢條線飛走，你見到呢兩條線之間嘅距離越嚟越闊嘅，咁咪叫 diverge 咯 ，divergent。OK， 得唔得？好，到呢個啦，所謂 upward，即係話將呢個嘢咧就騰高啲，點算啊？高啲喎，OK，騰高啲咁點算咧？ 答案係咁樣，係錯嘅。OK， 嗱呢個虛線錯嘅呢個答案，點解咧？佢衰咧就衰中間嗰條線，咁所以啦呢個答案唔出我嘅答案。原來當你褪咗上去咁點啊？好正㗎，因為其實咧我哋暗地裏知道呢個 focus 嚟嘅，因為穿 focus 平衡出第三個烏，唔記得嘅貼翻上前邊個板，第三個烏穿個 focus 就平出。咁仲有 first rule， 你任何光線穿中間都係直線嘅。仲有做實驗嗰度咪話俾你聽嘅，如果你有3條平行光線，佢會聚焦，但係如果佢歪咗，即係咁樣歪咗嘅時候點咧？佢都會聚焦喺 focal plane。所以啦，睇住嗱呢條線咧，我畫得差啦嚇，直線嚟㗎，大家同我畫翻條直線。OK， 咁跟住啊，佢有4方8面嘅光喎，可能有條咁樣去嘅，咁點算啊？好型㗎！任何 light source 喺個 focal plane 之上，總之佢個光喺 focal plane 之上，佢出嚟一定 parallel to each other。呢條線同呢條線同我求其畫一條線都係平衡出嘅，得唔得？嗱咁所以啦，佢出嚟呢個答案係錯嘅嚇，所以最後尾佢問你啦，咁最後尾點啊？因為呢3條光線都係平衡出嘅，咁所以答案咧就係 parallel 啦。嗱佢嘅答案唔好理，畫我嗰個答案啦，好簡單，你只需要將個 source 褪上，最緊要條線穿中間直去，求其畫條平行線，跟住但係呢條平行線啦嚇，平衡個 principal axis 出嚟嗰條線咧，一定同呢條線平衡。呢條咧任你畫平衡咁就得㗎。好，打個鐘啦嚇。第2、第3條唔講啦。OK， 咁我提我喎嚇。Chapter 2同埋 3咧就未做嘅，你自己諗下。我哋下一堂咧就講一講。嗱呢啲係 Level 4問題嚟㗎嚇，大家要有能力處理。OK， 有冇人有問題？好，如果冇咧，咁就落堂啦。咁大家預備上下一堂。